Okay, so today is Thursday, October 4th. The first part of your opener today says, factor each of the following. Write answers in standard form and exponential form. Now, if you remember, this is the very first set of notes that we completed for second triad. The main thing that you need to remember about these type of problems is that if there is not a square root sign, do not put a square root sign. So, for example, we have 90. We need to factor it, and then we need to write those prime numbers in standard form and then exponential form. So the first thing I'm going to do is factor 90. I'm going to use the factors 9 and 10. You may choose to do something different. It does not matter as long as we end up with the same prime numbers circled. I then come up to the right. Now, keep in mind, there is not a square root sign anywhere on this problem, so I do not add one in. I'm going to simply rewrite my prime numbers in order from least to greatest to show that it is written in standard form. Then, after I write it in standard form, I'm going to write it in exponential form, which is going to be 2 times 3 to the second times 5. And then that is my final answer. Now I'm going to factor 160. Two factors that I can multiply together to get the product of 160 will be 10 and 16. Keep in mind there are so many different factors that you can multiply together to get 160. I'm choosing to use 10 and 16. I'm going to circle my 2 and my 5 because they're prime. And then I'm going to factor my 8, which is 2 times 4. I circle my 2 because it's prime, and then I factor my 4. I then take my prime numbers and I write them in standard form, which is order of least to greatest. I have 5 2's, so I'm going to write 2 times 2 times 2 times 2 times 2. So I have 1, 2, 3, 4, 5. Then my last prime number is times 5. From exponential form, I'm now going to write them in standard form, which is going to be 2 to the 5th times 5. That's my final answer, so I'm going to box it. All right, the last one that I'm going to factor and then write in standard form and exponential form is going to be 180. I'm going to use 10 and 18 as my factors. I then factor 10 by 2 and 5. I'm going to circle the 2 and the 5 because they're prime. For my 18, I'm going to use 3 and 6. Circle my 3 because it's prime. And then factor my 6, it's 2 and 3. I go up to the right. I write my prime numbers in standard form. It's going to be 2 times 2 times 3 times 3 times 5. Exponential form will then be 2 to the second times 3 to the second times 5. And then box your final answer. All right, let's take a look at the next part. The next part is evaluate each of the following. Be sure to show all of your work. So when we go to evaluate each of the following and be sure to show of our work, we are dealing with square roots. So pay attention that there is now, in fact, a square root sign. So the first thing I'm going to do is that I'm going to type into my calculator the square root of 64 to see if it ends up being a perfect square, which it does. So remember, to show that the square root of 64 is equal to 8, we're going to put the square root of 8 squared and show that squared and square root cancels and equals just the basic 8. Go down to my next one. I have the square root of 121. Again, before I go ahead and factor out the radicand, which is the inside number here, I'm going to go ahead and see if the square root of 121 is a perfect square. So I'm going to type into my calculator square root 121 equals, and when I do that, I actually found out that the square root of 121 is in fact a perfect square, so it's going to be 11. Again, so I put my 11, my square root sign, my squared sign. I show that square and square root are inverse operations and that they cancel, and I am left with just 11. Moving down to the next one, I have the square root of 7 times 7. Now, I can solve this one in different ways, but what I'm going to do is think back about the notes that we took Monday and Tuesday, simplifying square roots. Well, when I have my prime numbers under the square root sign, I can skip and go down to step 2 where it says circle my factor pairs. Well, right there are my pairs. Moving to step 3 then, it cancels with the square root sign and moves to a single number on the outside, which would just be a single 7. You don't have to write both methods, but another way of doing it would be 7 times 7 equals the square root of 49, which would end up being a perfect square of 7, and showing your work like that as well. To me, the work in the red is extra, so I would prefer to show my work in the manner that I did with the pink pen. All right, last one here. We have the square root of 2 times 2 times 3 times 3 times 5 times 5. First thing I'm going to do, instead of multiplying all those together, I'm just going to circle all my factor pairs. Now, looking at this automatically, I know that since they're all factor pairs and there's no numbers left over, that this is a perfect square. So I'm not going to end up with a radicand or a number under the square root sign. So my 2 cancels, moves to the outside, my 3's cancel, moves to the outside, and my 5's cancel and moves to the outside of the square root sign, all as coefficients. I'm going to take 2 times 3 to get 6, then 6 times 5 to get 30 as my final answer.